Myself Ashok, Assistant Professor, Computer Science Department from Rohini College of Engineering. In this video, we are going to see about intercloud architecture. In intercloud, there are three main parts. One is resource provisioning, second one is resource provisioning methods, and third one is global exchange of cloud resources. First, see about resource provisioning of computing resources. So, resource provisioning means provisioning of computing resources, the action of providing or supplying cloud resources for the use. For example, virtual machines. Providers supply cloud services by signing SLAs with end users. The SLA must commit sufficient resources such as CPU, memory, and bandwidth that the users can use for a period. Under provisioning of resources will lead to broken service level agreement and penalties. Over provisioning of resources leads to resource underutilization and consequently decrease of revenue for the provider. Deploying an autonomous system to efficiently provision resources to users is a challenging problem. The difficulty comes from the unpredictability of consumer demands, software and hardware failures, heterogeneity of services, power management, conflicts in signed service level agreements between consumers and service providers. The efficient virtual machine provisioning depends on the cloud architecture and management of cloud infrastructures. Resource provisioning schemes also demand fast delivery of services and data in cloud computing infrastructures. In a virtualized cluster of servers that demands efficient installation of virtual machines, live virtual machine migrations, fast recovery from failures, for example, virtual machine monitor. The next thing is demand-driven resource provisioning. In resource provisioning, next we are going to see about demand-driven resource provisioning. So add or remove computing instances or resources based on the current utilization level of the allocated resources. When resource is executed, a threshold for a certain amount of time, resource could be increased based on demand. When resource is below threshold for a certain amount of time, that resource could be decreased accordingly. Second thing is event driven resource provisioning. The scheme add or remove machines instances based on a specific time event. So it works better for seasonal or predicted events such as Christmas time, New Year, etc. During these events, the number of user grows and both the event period then decreases during the event period. And the third one is popularity driven resource provision. In this method, the internet searches popularity of certain applications and creates the instances by popularity demand. The scheme predicts increased traffic with popularity. Again, the scheme has a minimal loss of quality of service if the predicted popularity is correct. Resources may be wasted if traffic does not occur as expected. And the third thing is global exchange of cloud resources. In order to supply a large number of application service consumers from around the world, cloud infrastructure providers have established data centers in multiple geographical locations to provide redundancy and ensure reliability in case of site failures. For example, Amazon has data centers in United States and Europe. Amazon expects its cloud consumers to express uh, uh, preference regarding where they want their application services to be hosted. Amazon does not provide seamless automatic mechanisms for scaling its hosted services across multiple geographically distributed data centers. So you can see the high level components of the Melbourne group of intercloud architecture. Thank you.